Great. Well, we are at the top of the hour. Hi, everyone. Welcome. My name is Shelby Arndt, and thank you for tuning in to the USGS Landslide Hazard Seminar. This meeting is hosted by the Landslide Hazards Program and co-organized with John Perkins and Jamie Kostelnik. For those of you who are new to this meeting, you can submit questions via the chat window or use the raise your hand feature along with microphone and your video camera. And we'll wait till the end of the presentation to take questions. In the meantime, please do your best to make sure your microphone is muted when you aren't intending to speak. Today, we have our second presentation in our mini-series on landslide response in Appalachia during Hurricane. My pleasure to introduce our speaker, Jennifer Bauer, who is Principal Geological Owner of Appalachian Landslide Consultants in Asheville, North Carolina. She started Appalachian Landslide Consultants in December of 2011 after working with the North Carolina Geological Survey landslides mapping team. Prior to that, Jennifer worked at an engineering consulting firm in Raleigh, North Carolina, after receiving her bachelor's with highest honors in geology from the University of North Carolina in Chapel Hill. She is a past president of the Association of Environmental and Engineering Geologists and a member of the Federal Advisory Committee on Landslides. Jennifer has over 24 years of experience and is passionate about applying her work to protect lives, property, and infrastructure. And today, she is going to talk about some of that work towards understanding landslides triggered during Hurricane Helene. So with that, you can take it away, Jennifer.
Great. Thank you for inviting me to be part of this Helene mini-series. As you can imagine, we've been trying to respond to as many landslides as we can. So it was nice that this was in April and not in January. So thank you. Thanks to everybody for attending. I appreciate your attention and interest in this topic. And today I want to talk about using landslide maps and really an understanding of the landslide that we get through the inventories that we create to really help people make decisions about where they're living, where they're building, where they're placing infrastructure, that kind of thing. But I want to do it through stories and pictures. So you're pretty much going to get a story for this whole hour. But I wanted to start with a story from one of our clients. So we do individual property evaluations for people when they are trying to decide which home they want or which property they want. And we worked with this woman prior to Helene a few years ago. And right after Helene, she sent me this email. She said, "I'll make this short and sweet. I just want to say thank you both, me and Philip Prince, one of the geologists that works with us, for your expertise 3 years ago when I asked you to provide help as I was buying properties in the Blue Ridge. Our house and our family were safe, even though Burnsville had many catastrophic mudslides and floods. So many of the properties I had been wanting to purchase that you steered me away from had cataclysmic results or are completely gone now. I cannot thank you enough. You truly saved us. Your work is important, even if it's only accentuated in big events like these. The daily tasks you do have long-lasting impacts." And that really, right after the storm, let me know that we were doing the right thing, that I was in the right place. So she sent me this video that she took prior to Helene. This was from 2021. This is in the Bat Cave area. And it's this nice, beautiful property, a flowing stream running through it. They had intentions of putting home down there next to the stream. And there's a road and lots of kudzu, steep slope above. So this is one that she was interested in. And we took a look at the data that we had. And one of those items was the Henderson County landslide hazard maps that we had put together when the North Carolina Geological Survey first round of landslide mapping took place. And we looked at the landslide database just to see what had been mapped in this area. And we saw a debris flow that had occurred in 2018, others in the area as well. We saw this orange outline here indicating that there were old landslide deposits in this area. The property of interest is where this green dot is right in here. We also knew the stream was running through here, so we considered flood hazards. We took a look at the landslide susceptibility map that our company has put together, and these indicate areas where debris flows starting from non-constructed slopes may start, and those are the purple areas you can see here. There's quite a few that are upslope of this property, and then other areas that are considered slope construction caution areas if they were to be modified in any way, where you would need to have an engineer involved. So we told her, we don't think this is the place for you, in different words. But so she went back out there after Helene and sent us this video of the same property. You can see flooding damage, where their home was probably completely covered. There's a landslide in the background. The road was destroyed. There's a cut slope failure here, another cut slope failure here. A debris flow had come down back behind the location. So this is why she sent us this email. And that's just one of the stories that we've heard from other people that we have helped. But it's an indication of the work that we are all doing, all of us on this call, landslide related in some way. What we do can really help people make smart decisions. And that's what this whole talk is about. One of the things I wanted to share, I know Ben covered, or the previous presentation covered the rain story of Helene, but one of the things that I think is really important for all of us to remember is that the National Weather Service scientists are doing an amazing job with their forecasts. And these are some of the messages that they sent out during the storm. One of them was saying that this will be one of the most significant weather events to happen in the modern era, record flooding compared to the 1916 event, which was the flood of record prior to this. They also said that there will be significant to catastrophic life-threatening flooding. They never say catastrophic unless they mean it. And they mentioned that many landslides will occur as a result, with a few large and severely damaging slope failures or debris flows. And I'd say that they were spot on, except it went from a few to thousands. So I want to talk just a little bit about the inventory that we do have in North Carolina. We're fortunate to have a landslide mapping program that has gone through a few iterations. From 2005 to 2011, the North Carolina Geological Survey had a landslide hazard mapping program that me and my business partner and several others were a part of. And we completed mapping in the counties that are in blue, so Buncombe, Henderson, Macon, and Watauga counties. And then in 2011, that program lost its funding. So my business partner, Stephen Femmeler, and I started Appalachian Landslide Consultants to continue offering this landslide service. And we did mapping in Jackson County and portions of Haywood County. And then in 2019, the NCGS had a landslide mapping program that was funded again, and they contracted out a portion of that. So now we work with the NCGS to do mapping, and we've completed Polk, Rutherford, Transylvania. McDowell is in the very last days of getting finished up, and then we're working on Haywood County now. So just to give you a sense of the inventory prior to Helene, all these red points, you can kind of see which counties have been mapped and which ones haven't based on where the points are, but there's probably somewhere around 9,700 if you combine all the databases together prior to Helene. And then if you add on the USGS laser points, then you could really see there's going to be a whole map covered probably after all of the inventory actually gets sketched out. Ben mentioned that for every one of these points, there are likely 2 or 3 others that weren't caught by the laser survey, and I would say that's definitely true from my experience. So the number will probably be closer to 6,000 or 7,000 rather than around 2,000, just from Helene. Right after Helene, separate from the USGS efforts, the North Carolina Department of Transportation also did an inventory of all of the roads that were impacted by landslides. And this is what that inventory looks like. They captured, our team was part of a larger team that worked on capturing that data. And there were over 1,100 points, 1,100 locations that were either fill slope failures, cut slope failures, or debris flow impacts along the roadways. And all of these were field verified. Here's just one of those. This is a video I've gotten off of YouTube posted by Alan Keffer. He's driving from Black Mountain to Old Fort right when all this happens. And if you could hear the video, I'm sorry you can't, right when that hit, right before that hits, he says, whoa. So I urge you to check that out on YouTube if you get a chance. But here's what he was driving just in front of. This is a big debris flow, debris blowout that came from upslope here above the Interstate 40. This was the main, one of the main thoroughfares between the mountains and the Piedmont. Essentially, this is right at the top of the Blue Ridge Escarpment. And this cut was one of the interstates that was cut off immediately after Helene because of this landslide. And this slope had failed 8 times prior to this. So definitely reactivation in the same location. There's a very active spring in this area, which is likely the main culprit for this recurrence here. Because we are working on Haywood County, that's the area that I've been focusing on, and wanted to give you a few statistics because that's the area I have most of my field experience in. And Haywood did not get as much rain as Buncombe and many of the other counties along the Blue Ridge Escarpment there, but it had 174 Helene-related landslides, which are the ones that are here in triangles. All of the red points are the ones that we've mapped prior to Helene. So you can see that the Helene points are occurring in the areas where we had prior landslides. These watersheds have not yet been mapped in detail. So I suspect there are old ones near where a lot of these new ones are as well. But some statistics related to these that we've collected so far, and just for comparison, there were 48 USGS laser points in Haywood County, and we have 174 that we know of so far. So that's we're seeing 3.6 more in the field than were captured from the laser review. So that fits in with the 2 to 3, or I guess it's 3 to 4 out there for every one laser point that's out there, if this can be extrapolated to the rest of the Western North Carolina. I don't know, we'll see. But I've looked at some of the statistics, at least for Haywood County, and 40% of the ones that are in the Helene-related landslides that we've mapped so far are on non-constructed slopes. So these are slopes that have likely been logged at some point. But so if we call that just that's equal everywhere. So a non-factor as far as differentiating things. There's no construction, no evidence of roads or trails or anything like that. And there's 40% of the Helene ones are on those non-constructed slopes, and 59% of them are on constructed slopes. So those are cuts or fills or some type of embankment. And that's something that we can learn from, because humans are the ones that are constructing those slopes. So that's something, I don't know if these same statistics could be extrapolated to the rest of the Helene related ones. I doubt it. Haywood has a lot of constructed steep slopes, whereas there's a lot of national forest slopes in other parts of Western North Carolina that may or may not have had construction going on those slopes. So we'll see what the numbers shake out to be after the inventory is complete. In Haywood, there were 6 structures destroyed. 2 of those were homes and 20 other structures damaged. So Haywood has been through lots of landslide events, and they're still going through it, sadly. So here's some examples of fill slopes that are failing, as well as some non-constructed slopes that are failing, that have failed during Helene. This is a flight I got to take on a helicopter with the National Guard to look at landslides in Haywood County. And I wanted to look at some of the statistics because we had done mapping in 4 of the watersheds for Haywood County. And we created landslide susceptibility maps in these 4 watersheds as well that are outlined in blue here. So we took a look at the statistics for the model, and we have different modeled areas. One is what we called where natural debris flows might start, which we tried to keep the words really simple because we are trying to communicate to the public about these areas. And when we did this mapping, we really had a lot of communication with stakeholders and people from all backgrounds to really get an understanding of what they needed to be able to understand the maps. So we created these models with that in mind. And we used the colors that we did because of the feedback we got. They didn't want red everywhere, so we didn't use red. So we have the different areas, one showing the initiation zones or potential initiation zones. And this is an empirical model based on the geomorphic characteristics of where the debris flows on non-constructed slopes had occurred within the county in the database that we had. So that's the purple area. And then we wanted to show people downslope where their hazard might be. And this was a similar model to what we had used at the NCGS, the debris flow pathways model that we modified just a bit to make it a little bit more efficient to run. And that shows where the debris flows might go. And those primarily follow the flow paths down. We were using LiDAR from 2005 at the time. And then we have a third layer called the slope construction caution area, which shows people if you are constructing on these steep slopes, make sure that you're doing it with an engineer involved and really careful construction, because we were seeing such a high number of those constructed slope failures, and we wanted people to be aware of when they needed to really be careful. So those are the different model layers that we have. And we took a look at the Helene points, and 54 of the debris flows and blowouts in the database that occurred on non-constructed slopes, which is what the model shows, are within in or within the 1 pixel of either of these database or these modeled areas. So that's a pretty good capture rate. So, there 50 of them out of 54 are captured in the model. And then when we looked at the constructed slope landslides, because there's so many of them, we looked at, there are 98 of the 102 constructed slopes that are within the slope construction caution area, which makes sense. It's a pretty broad area, but it's pretty good capture rate for those models. So I want to move into some Helene landslide examples and the different types that we're seeing in Western North Carolina. And some of these are from Haywood, some of these are from other property evaluations that we've done or client requests. So you'll get to see some examples here. This is one from Haywood County. This is a lot of the debris flows that we see are within colluvium, right, very close to the ridge tops, not right on the ridge tops, but off the steep edges of the ridges. And then they travel down the drainages, often scouring all the way down to bedrock. And then when they get to the flatter slopes, they will then fan out, like this one here did. And it fanned out, it hit a garage that used to be here. Fortunately, no one was injured. They lost a car, but car insurance got them a new one very quickly. And it fanned out, did not damage this here, but it did spread out there at the base. And this is a drone photo that we were able to take of the initiation zone. You can see it's relatively shallow colluvial soil right on top of a really steep bedrock surface. And we've seen a lot of those from Helene. This one we compared to the models that we have, and it fell within that where natural debris flows might start area. The track followed pretty closely where the natural debris flows might go model, but you can see at the bottom, because we were running a county-wide model, a watershed-wide model, we didn't have the modeling to show where it might fan out at the base. And I think there's still a lot of work that can be done. So if any of you are into that, this is a great example and opportunity for figuring out how to take something skinny and make it wide down at the base to really give a sense of what the hazard is. But in general, the pathway was what the debris flow had followed. And we see this time and time again, where it's the drainages that really get impacted and then things spread out. Here's another example, and this I have a video to show you what one of these debris flow tracks looks like. This is up in some very steep ground up in Haywood County. The map on the left shows a slope overlay over the LiDAR hillshade, and then this video is showing the looking up at the headscarp, again, bedrock, shallow colluvium, and then it kind of spreads out. Some of this is deposited on top, some of it is scoured into the track. You can see the mud lines, how high they are up on these trees. So it's a pretty fast moving, very viscous or very liquefied. There's a lot of water flowing through this system. And then at the base, this all spread out very close to this cabin. The cabin is right where the pointer is showing right now. And this debris flow, as it's got to that flat area, spread out at the bottom and then covered the river, it covered the road. And this landowner actually had to try and build a little makeshift bridge to get out because their driveway was completely destroyed because of this. This is another example of one that started within those modeled areas as well. Here's what the base of it looks like. Down at the bottom, we came in October, so the stream had already made its way back through. DOT had already cleared the road, but it gives you a sense of how wide this debris was when it got to the base. Here's another example of a debris flow in Haywood County. This one was also on a non-constructed slope. This is looking up at the initiation zone, and it's, again, relatively shallow colluvium. There's bedrock in the base, but this one had a very precariously perched boulder sitting on top. And we were concerned about this boulder making its way down to this home that was splashed by mud from this debris flow, but otherwise not structurally damaged. The folks here wanted to know if they could move back in with this. And so my business partner went up there and did an evaluation and told them he thought that this boulder needed to go before they could safely stay there. So we gave them the name of some contractors that can do boulder removal. I'm not sure the status of this now. This is looking at that same debris flow on the Sentinel satellite imagery that was taken October 12th after the storm. A lot of the laser points were collected from using this imagery. And the red square here is that home. You can see how it just skirted the edge of it. This is the model, and it starts within the area where debris flows might start, and it partially follows the debris flow path down the stream, but there's a road here that the flow paths thought the water would flow under and around, but the debris flow decided it would flow over, and it crossed and then just continued down this flatter slope here. So this is one area where the model didn't quite capture where the debris flow would go. So there's more research to be done as to how do we prevent this type of thing, or capture or better understand when our debris flow is going to just go where they want and not where the model thinks they will. So as I mentioned, there's an abundance of constructed slope failures in Haywood County, and here's an example of one of them. And these have happened not just in Haywood County, but all over the place. So many edges of roads have failed, and you can even see the cracking indicating this was having issues prior to the slide. This fill slope doesn't even look like a very big slide. It's probably, I don't know, 50 feet across maybe, but it let loose, flowed down this slope here, and picked up enough steam that it pushed this home and kind of crumpled it against some of these trees. And you can see this fill slope right up back behind. This home had just been purchased by some folks from Florida. Fortunately, the people who were staying in it evacuated, or they left right before Helene, so no one was in it. But the folks who had bought it had just bought it a month before, and they were down in Florida in their Florida home, and it was damaged by Milton, which was right after Helene. So they had two homes, both damaged by hurricanes. Feel for them. Here's another example of a fill slope failure in Haywood County, and how this one, the contractor was doing an extension of the deck on this cabin that had been there for decades, and everything was fine. But they wanted an extra portion of their deck. So he drilled the foundation, and he thought that he had found bedrock, but it turned out, upon evaluation of the slope that had not yet failed, it was actually a slope covered in boulders, and he had found boulders to put his foundation footers on. And also at the time, the deck did not have gutters yet, and so all the water was just running right off of the roof, right onto this fill slope. And that slope was just not meant to have all of that water on it. It failed in debris flow style all the way down to this home below, hitting a garage. And this is that garage. It used to be 2 stories, and now it is 1. Fortunately, it was detached from the home, so the home was okay, and the people, the owners are here, and they're fine. But they did lose a couple of cars, and now they have to figure out how to clean all of this up. The debris flow hit here, it went down their driveway and just covered their whole area. Here's another example of a fill slope failure in Haywood County, and this one was right off the edge of this foundation, so much so that the foundation is now exposed. And the woman who owns this house, she was here, and there used to be a portion of a deck sticking off this edge right here that you can see. And she said she kept looking out the window, and she noticed her grill was leaning back a little bit, and then a little bit later it was leaning back a little bit more, and then she looked and the grill was gone. So this slope must have been slowly sliding down, and then it completely failed and took a portion of her deck with it. And this had continued to fail even after Helene, whenever it would rain. You can see her gutter drains were right here onto the slope. I don't know that this was extended prior to the storm. So that's something that we talk to landowners about, is just how, or homeowners, how important it is that the gutter drains be piped completely away from the home, off of any fill, down all the way onto natural ground if possible, just to get it away from the house. This is that last picture is right in this area of Haywood County, and all of the yellow polygons are landslides in the past inventory that have occurred in this area, dating back to the 90s even. So there's one more to add to that list, and then the red triangles are Helene points. So we've got 4 more to add to this neighborhood. This neighborhood also had another slide that reactivated within a fill slope. I know some of you are asking, and we get asked all the time, are these landslides, do they happen in the same place again, or are those cleaned out? And it really depends on the source material. So in my experience, if it's a soil source where the soil is still available, then there's the potential for it to be reactivated. And this is an example of that. So you can see the slope up here has failed again, and has caused all of this debris to cover up one of these roads again and go all the way down to the creek. I'll see if you can see the source area again. So this road up here is this road up here, and this landslide actually failed within the slope. So it wasn't all the way at the top, it was partway down. But it's just one example of the few that we have seen that have reactivated. Here's another example of one that's been reactivated. This one is in Buncombe County, and this area that's outlined in yellow is looking at the 2017 LIDAR, so pre-Helene, obviously. But you can see it's a pretty clear scarp, and then the debris pile just continues down the slope here. So I went out to actually look at some property for this landowner here, and he's like, oh yeah, I have another landslide up above, because he had one off of the fill slope here. And I said, oh yeah, well, let's walk up and see it. So he showed me this one, and it is huge. It looks like a slide that then transitioned into a flow. It's probably, I don't know, 500 feet wide or so, a couple of different initiation zones, and then flowed on down into the neighborhood and damaged their driveway down there. So looking at the scarp again, it's within weathered rock, and parts of it are on pretty competent rock, and then other parts are completely decomposed. So this is going back to that, is there still source? Could this still fail? I would say for this one, it could fail again, because we still have a lot of that weathered rock that's completely turned to soil that's available. And in this case, we have fractures, exfoliation fractures within the rock that are covered in clay and manganese, coated in manganese, and we see so many slides on manganese coated surfaces. So there's a place for groundwater to flow, and a slide plane that could exist already. So if there are any other of these clay coated surfaces back in the rock, then those could be potential future slide planes. So we've talked about debris flows a lot now. I wanted to show you a feature that has been called debris blowouts. And these are ones that have been described to burst forth from the ground. And it takes a lot of rain to make this happen. They're definitely groundwater driven. And I spoke to a dams engineer, and he said, oh, this is just like static liquefaction. So it's a phenomenon where the groundwater just it can't stay contained anymore. And somebody in Watauga County actually got a video of one of these. So I'll show you this video, and it's pretty viscous fluid, and then it just completely breaks up and flows over the surface. And the people who are in the video, they're saying, like, I'm okay, my car's gone. And the woman in the video is like, it's okay, everything's okay. And she's asking, like, is everybody okay? Was anybody in the gym? Because this part of the garage got torn off. And then if you look at it afterward, the grass is still intact. There's no scouring down of any of the grass or anything. So this is one of those characteristics that helps us determine, was this a blowout style or was this a debris flow? And sometimes one transitions to another. So I'll show you just kind of in slower motion here. Here's that package of soil that's somewhat intact. It has a lot of water in it coming down the slope, and then it reaches the point, and then it's almost like it explodes. And I don't know if the transitions are working for you all, but then here's the picture of it just kind of going up into the air, which is pretty crazy. And then when you look at it, the source area, it's this tiny little circle that has moved all of that material, all these trees, and pushed that garage apart from its house. Philip Prince went up there to take a look at this, and there was definitely signs of groundwater activity in this area too. So that's a video of a blowout. We've seen lots of evidence of them. We knew they happened in Watauga County in 1940, and we know there are many of them contributed to Helene as well. This is a neighborhood that we were called to check out and take a look at after Helene, because there were 2 homes damaged, or destroyed rather, one beneath this debris flow in letter A, and then one in B. This area, this structure right here, was hit. This area, you can also see on the LIDAR, there's some old landslide scars here and here, indicating that maybe this is has been an active area in the past. So we'll look at this area A first, and this is a debris flow that started up here on a non-constructed slope. Nothing on the LiDAR that's indicating any roads, trails, activity at all. And it let loose. It crossed the driveway above this house. The house used to be sitting right here and was pushed and turned into splinters down here. And there was a young woman and her father in the home when this happened. And miraculously, they survived it. She had a broken finger. He was in the hospital for a little bit, but they were okay, which just blows my mind. We have so many stories of people who survived these things and in houses that look like this. So we looked at the susceptibility map to try and give them a sense of, is this area a continued hazard or not? And we noticed that there are a few of the features that did start within the susceptibility area, the modeled where natural debris flows might start area, but this A one did not. And we think it's because we used the 2005 LiDAR. It didn't have any, it had 6-meter resolution pixels, and perhaps this one is just on such a planar slope that any of that, if there was any convergence of water, it wasn't taking place in that area on the LiDAR anyway. And that's one of the factors that's put into the model. So the model did not capture this planar slope here. But the next one I'll show you is this little feature here. See, this is actually a blowout that then the water converged with a spring and turned into a debris flow. So here's the video looking up at the top of the debris flow, and it has a little lip down at the base of it, which many of these blowouts do. They look like little ice cream scoops. And there's no scouring on the slope here. It's all surface flow until you get down here, and then it starts to erode, and we get an erosion triggered debris flow down below that. I had a little cat that was hiking with me, which was a lot of fun, little geo cat there. So I looked at in the headscarp, and it's primarily bedrock. There's a little bit of colluvium at the top, but there's bedrock all the way very close to the top of the initiation zone. And I noticed where the majority of the water had flowed after Helene, and traced that up to this big crack in the rock. This probe I'm holding is about 2 feet long, and the crack just kept going back in there. And I suspect that groundwater was flowing out of this crack, and that's what caused this blowout, is that maybe that pressure, maybe the crack was a little closer before all the groundwater was flowing out of it. I don't know, but there's definitely fracture flow that has contributed to some of these blowouts as well. One thing I'll note is that the people in this community said that they have springs all over the place, and that their community well, which was down in this area, was actually flowing artesianally during Helene. Like water was coming up out of the well. So there's a lot of groundwater action in this area, which could be why there's so many landslides in the area. Let's see. So the next feature, we don't have very many debris slides in the database, at least debris slides that don't transition into debris flows. But I do have a picture of one. Although, there it is. It's a cut slip failure. Not super exciting, but failed within colluvium with a little bit of rock at the base of it. But so these are the types of debris slides we see where the slide block stays intact. There are many, many where the features slide and then turn into a flow. And then just to round it out, I'll show you some weathered rock slides. These are on non-constructed slopes. This is from the helicopter ride in Haywood County on farm fields. You can see there's intact blocks that have slid a little down the slope but haven't completely mobilized, or this one is partially mobilized. These can be a continued hazard for future rain events, but fortunately in this case, there's not a whole lot downslope as long as the cows aren't there during that. So hopefully they'll be okay. But we also do have weather rock slides on constructed slopes, like this one, which was in Yancey County, right behind a home down here. It looks like there's a lot of drains that were coming into it, and water that was likely contributing to this slide here. So one of the things that we don't talk about much, but that can be a really important tool when we are thinking about how to help people understand landslides and where they might happen, are the landslide deposits that have been mapped. So the North Carolina Geological Survey inventory includes landslide deposits. And this is a screenshot from the Buncombe County maps that were put together. And this is a view of the south side of I-40. So the Swananoa Mountains are kind of on the uphill side of this image. And all of these areas that are outlined in this orange are mapped landslide deposits. And they're all in these valleys at the base of this ridge here. And the Southeast Friends of the Pleistocene group did a field trip a couple weeks ago, led by Brad Johnson with Davidson, to this big deposit here, which is near the YMCA Blue Ridge Assembly, and some friends of his actually have property up here. So we were able to go up to this area and get the area that was impacted by Helene. So here's a zoom in. This LiDAR is from 2017. We don't have post-Helene LiDAR yet. But even in this, you can see the deposit features, just how it kind of fans out. You can see it's a much broader morphology compared to a lot of the bedrock ridges. And these deposits were drawn on the 2005 LiDAR, the 6-meter pixel resolution LiDAR, but they do a pretty good job of capturing the deposits still. And when we got there, let this catch up. We were talking a little bit about the we were talking a lot about the Helene debris flows, and we took a look at the laser, or I took a look at the laser points in this area, and there are several mapped in this vicinity. You can kind of see some of the debris flows that started in the Sentinel imagery near the top here. And I took some notes while we were out there. This is just kind of my chicken scratch indicating where we had seen some debris flows. And there's one that's unmapped here, but there are several more than just the points that you could see on the imagery. And there are a whole bunch more to be added up here. Ben talked about one that they saw up in this area here. But as we were hiking up this debris flow track, I noticed there's a lot of exposed old landslide deposit right where we had mapped it within this old landslide deposit area. So this is the debris flow track, the recent one, and this is the incision into the old landslide deposits. So this gives you a sense of what it looks like. This is Brad Johnson here contemplating the multiple debris flows that must have occurred to lay down boulders in this area. And this is right along this edge of this orange mapped debris flow. And then so that gives you a sense of where we're looking here. And then on the other side of the creek, right along this ridge, actually, there were still landslide deposits, which surprised me a little bit. I thought this is probably bedrock ridge, but it must be armored with some landslide deposit as well, because this is what we saw on that side. And this is Arthur Mershot taking a closer look at different grain sizes that we're seeing here. And this was all debris. It was not weathered rock. We could see an old organic layer even. So some of this might have not scoured when it was being deposited. I don't know. There's a lot more work that could be done. But we looked a little closer and we noticed this real fine-grained area, or fine-grained portion of this cross-section, and we thought, well, maybe it was a debris log jam or something that had backed up things enough for the sediment to settle eventually. And because just one drainage over, we saw a massive log jam that has a lot of debris behind it, and it didn't pond, but if it had, it probably would have caused maybe some settlement of the the debris that was entrained in the water. And we've seen that in other places in Western North Carolina. And then you get these massive imbricated boulders right on top of all of that. So it's a great example of this repeated nature of how debris flows happen in the same place over and over and over again. And that's really one of the things that we can use when we are trying to help people understand the landslide hazard and how they can use that information to make decisions about where they're living, where they're putting their families, where they want to be during storm events. And so that ties into how critical the inventories are and how critical it is that we have the landslide initiation locations, the runout locations, these deposit locations, how they all work together to provide pieces of the puzzle that can really help people understand. And we can use those locations to create models that can indicate areas where these types of landslides might happen again. So people can use those for locating, I don't know if safer is the right word, but areas that are less likely to be impacted by landslides. And these models then lead to areas that need to be evaluated on a site-specific basis. Because if we're doing modeling that's covering the whole area, it might not work for one place as well as it works for another. So we can use that tide with boots on the ground to help make specific observations by qualified geoscientists. And then we take all this information and share it, because we can't just keep it on the shelf. We can work with planners, emergency managers and responders, developers, all those types of folks to really put this information we're gathering into action. And that cross communication is really key. So that cross communication requires regional partners, which is one of the items that's included in the reauthorization of the Landslide Preparedness Act. So hopefully that will be passed, because this regional partnership is really how this information gets used. And those partners need to be made up of, this is just a short list, but geoscientists, meteorologists and climate scientists, emergency management and response, local and regional planning folks, real estate and building professionals. It's important that they're at the table so they can put their input into how this could be used and presented. The farmers, the private landowners, the developers are really important. And having social scientists part of that team to facilitate conversations among people who might not speak the same language, even though they're both, everyone is speaking the same language, they just are using different words that not everybody understands. And having local champions, that people that the locals trust, that they will listen to, that they'll agree to their buy-in, is really important in making this happen. So that's my opinion on how to use landslide maps as a life-saving tool, and I'm learning every day. So I really appreciate your attention, and I'm open to questions.